Welcome to another GC Basic tutorial video, call it what you like. This is part 6 using the reset button for the 16F175 chip family. I'll just let the logo complete. So we're using the reset switch on the 16F175 chip family. I am using a 175xx, I believe. And as I said, this is part 6 of about 20 videos I'm doing. So please like and subscribe. Like is important. Subscribe is even more important. Just want to get over the 1,000 this year. I'd be really grateful. So do subscribe. So where are we? We have made the hardware work at number 1. We've made some LEDs flash. We made the LEDs represent the value of an analog to digital conversion. And then we actually use that conversion value in tutorial 4 to make a delay so that when the LEDs rotate or change is dependent upon the value of the ADC. We used an 8-bit value in the ADC, and then we used a 12-bit value in the ADC. In the last tutorial, we used an input, a switch, to set the state of the LEDs. But this time we're going to use the reset switch. These particular microcontrollers do come with a reset switch, and we're going to use that in 2 ways. So, prerequisites, you've installed the software, you've got your programmer working, you've tested that you can talk to your 175 chip family, and you've got 4 LEDs operating. You have a potentiometer, and you have switches connected. Rather than switches, that implies more than one. And we're going to attach a switch to the particular port that's called the reset line. So, using a reset as an input or master clear, a particular pin or port, connection on that microcontroller is called the master clear. On this particular microcontroller, that's the RE3 pin. And it's multifunctional. And it's multifunctional on a whole range of PIC microcontrollers, not just this one. And many of them, more recently, can operate either as a digital input or a master clear, which is also called the reset signal. Hence, we called it reset. But the master clear has a particular, the M and the C of that means that that's what microchip use, the master clear. So master clear and reset are used interchangeably. There is a configuration control for the master clear register. It's one little bit in the thousands upon thousands of bits are available, and you can set that bit on or off, and they're called external EXT master clear, so EXT MCRL, and that means that you've enabled the master clear. External master clear enabled. The master clear, that RE3, functions as a reset. You push it, the microcontroller will reset. If it's int master clear, that's INT MCLR, internal master clear enabled, it means that it will operate as an input, not as an output. It's not constructed that way. Now, there are some design implications of doing this. If you want to use the hardware reset capability of the chip, which is someone pushing a button to reset the microcontroller, you would use the external master clear enabled. If you wanted to repurpose that as an input to use as button detection, you'd use internal master clear enabled, or int, the int part. So there's 2 levels of functionality, and we're going to see those operating. So let's have a look at my little chip I've been working on. Here is my chip. I'll go pull up the pointer, the pen. It's here, top left-hand corner here on this particular chip. RE3 MCLR master clear. I put another switch on there, and that switch has this circuit, very similar to the previous switch we connected to RA3. So it has a current limiting resistor of 1K, and then a pull-up to 5 volts. on the 10K, and that's the 1K and the 10K. So whenever I push that switch, it will ground. It will go to 0 and it will reset the chip and hold it in reset whilst you keep it grounded. And there are some real good uses for that, but I'll let you discover those uses. So this is my hardware diagram. Few circles there. It is not a Venn. Well, it is a Venn diagram. No, it's not a Venn diagram. I'm just showing you that on port E, on E3, I've got this master clear with a switch. I'll show you that now. Let me show you the hardware. Let me have a little cough. One moment, please. There we go. So I'm going to look at the desk cam. And here we go. Here's the microcontroller here. On my board here, the switch was already attached. It's down here. It says, for those that can see and look at home, I might be able to zoom in on that in reality. Let's have a look. Let's have a look. We can have a look at that. Move it to the right. There we go. Look. There is my master switch. It's a reset switch. I wish I could focus in on that then. Is that a 103? That'd be a 10K pull up there. And that is connected through to the microcontroller here on RE3, sorry, which is this top right hand corner here. There's no, I don't have any flying wires for that on my particular setup, but it does look, as I said previously, just like the wiring diagram that I showed you before. So that is how it's connected. Now I've got my 4 LEDs in here, and I'm going to actually use 2 of these LEDs to demonstrate this switch. So when I push the switch, different things are going to happen. Okay. So let me just go back and clear that slide and go back to my desktop. So just to recap, I have a switch, and that was what I was showing you there on that screen, on that video. So let's go through. So what we're going to do, the first part, we're going to look at it as RE3 as an input. The chip will be initialized, and then I'm going to push the reset switch, and if I push it, it will toggle the LED. The second part, if I use it as a reset, it will initialize, and every time I push it, it will reset. So how do I show you that? Well, what I've got is a little program, and what I'm going to do is I'm going to initialize the chip in this flow diagram. I'm going to come through, I'm going to flash an LED, I think it's 10 times, then it's going to loop round forever. Now, so each time it resets, it will flash an LED. It will only set the state of the LED when it's on the internal, because if it's on the external, it will just reset the chip. It will never get to this part of the program. It will just always reset. If it's on the internal, it will say, well, is the reset button high or low? And it will set the LED depending on what the state is. And then it will loop back and do it all again. So what we're going to see is the LEDs react in very different ways depending how we set the master clear. Now, I'm also going to show you some PICINFO and look at some sample code and look at that result. Let's get cracking. Into my desktop, I'm just going to press the Windows key, type GCS and go into GCStudio. It opens it up. I'll zoom in for you. I'll just turn the camera off. There we go. I'm just going to open up my recent programs, which is the chip range demonstrations, and they are in the demo boards. Open them up. I'm now inside of the IDE. We've seen this a few times now, and we've got the little terminal window at the bottom. You can shut that at any time by pressing that X on the right hand side there. So Control B is what I'm going to press. You can select this Explorer icon or Shift, Control Shift E. The one I'm going to use is 080 using the reset switch as an input. Click. I've opened it up. I'm going to close down that Explorer, and then we're going to look at the code. I've opened up the assembly, which is the wrong one. Let me just walk you through. Control F in here. I'm going to type in GCB and it will only show me the GCB files. And I'm going to set that filter by hitting that downward triangle. Now I know that's a GCB file and here is my source. Perfect. Control B to shut that window. So now we've got the same start as before. Anything in green is a comment. I'm not going to discuss that because I'm talking through it. I've defined my chip at 16F175xx. Option explicit means I'd have to define all my variables. I don't think I'm using many, to be honest. Right, here is the important part. Hash config. MCLRE equals int MCL. Well, where did that come from? It comes from deep inside the data sheet, inside the details of this microcontroller. But if you want to know it with ease, we're going to look in PICINFO. So if you press function key F4, it will give you a list. Select the task to run, type in PIC, and it will put PICINFO either in the top 3, but just pick PICINFO. And this is PICINFO. It's an application we've written a couple of years ago. And essentially what it is that's the best zoom I've got for you, is you can select the chip you're working on, and there are thousands of chips in here. Okay, so select the chip you're working on. You can do it at the bottom by doing a search, 16F175xx. That is the chip I'm working on. And as you saw that, it walks through many different chips. So if I want to go to a 10F202, the menus will all change because the information is specific to your chip. 16F175xx, my chip. The configuration options, we're looking at one configuration option, one, and I'm just going to move the screen slightly to the right. There we go. We're looking at one, and we're looking at the configuration, hash config, of MCLRE. But if you look on this menu here, there are many different configurations that you can change. Now, if it's got a star in front of it, that's the default. The default. So the star as the last character, that is the default. Great. So let's have a look at what my options are in here. INT, MCLR, and external, EXT, MCLR. So you don't have to memorize these. You can come into here and have a look. If you want to change something else, or you want to have a look at all of them, take the options tab, and here they are in their detail. This is the actual user interface that's actually been presented to you. It's been reworked. But look, you can see the master clear has 2 options, and therefore you don't have to go through the drop tab. And that was the options tab. Inside of PICINFO, you can find a lot more information around the chip itself, around the registers that are in use on this particular chip, all the bits, and the bits are bits of registers, and then the interrupts that have been handled properly. So, but we were looking at this particular one, which was the master clear. Now, where's it gone to? Here it is here. We've got 2 options. So you don't have to struggle. Just come into PICINFO, and then you can select it from there. You can change the configuration here and copy it by taking the copy config, and it will put it into your cut and paste buffer. So we've selected the default, which is int, the internal. Now, you can only change these when you're actually using what's called high voltage programming. If you are using a low voltage programming, then that would be using something like a PIC4, 5, then you can't do this. Not allowed. You have to have an additional circuit in your programming to make this work. So, one of the advantages of a PIC2 or PIC3 or PIC3 plus programmer is you can do high voltage programming, and you can do this, which I'm showing you today. Okay, let's get into the program. I've got 4 LEDs. We've seen those being defined before. I'm setting them as outputs. I'm setting a constant up for the reset button. and it's set as an input. Now, it's already done automatically for you. I'm doing that for clarity. Okay, let's flash the LED. So I'm going to flash an LED 10 times. How am I doing that? I'm using a special sort of loop, a repeat loop. You can repeat something a number of times and it will exit out. So repeat 10, it will flash the LEDs on and off 10 times, which is actually 5 flashes because it's on for once and then off the next. And it will wait. So we will see it flash. Then, if it gets through to this part of the program, because if I press the reset button, I would expect it to this loop, which it says here, if the reset button is low, then turn an LED on. If it's high, then turn it off. Now, so I've got RC1 as my sort of flag that the chip has been reset, and I've got RC2 as my sort of user interface, my feedback session. Now, so therefore, if it's on internal, I expect it to flash 5 times and then react to my button. Let's see what happens. We'll go to desk cam. I'm going to select function key F5 for speed, and that will then program it. As you can see, things are happening. Now, did that LED flash? That's the big question. How can I prove it to you that it flashed 5 times? I know what I'm going to do. I'm going to open up PICGit plus software, and I'm going to power cycle the chip. I'm going to power cycle the chip. Now I can just turn the power off to the chip by using the user interface. So I'm turning it on, it flashes 5 times. Turned it off 5 times. Good. Let me push this button. When I push this button, another LED should come on, and it does. Do you want me to zoom in on that? I think I should. Let me move it down. Oh, that's better. Look. Power on, 5 flashes. I push the reset button. Whenever I push it, it's on or off. So that's pushed, off, pushed off. So that means that it's an internal. It's set to the internal. Let's change our program. And what I'm going to do is change that to the external, and you'll see the difference. I'm going to program it, bring up my user interface software. 1, 2, 3, 4, 5. So it flashed 5 times, but I want to convince you that it wasn't the programming event making it do that. I've turned the power off. I'm turning the power back on. 1, 2, 3, 4, 5. There we go. Now, if I push this button here and then release it, it will flash it 5 times because it's resetting the chip. So to use the master clear, set it to external master clear. Make sure that you've got it pulled high. When you push the button, the circuit will go low. It will reset it, and the chip is resetting every time. How do I know? Because it's not going green. If I pushed that before, it would have been in the previous mode. So back into here, I'm just going to put my code back here because it's a demonstration piece of code. Reprogram it. So we're changing the functionality of the microcontroller. And if you had a bootloader, there we go, internal. Remember, internal is the default, so that's why it works, generally. If you're using a bootloader, having an external master clear is extremely useful. So the bootloader would then hold on for about looking for your new program for about a second or two, and then it would continue on. So it's great. That's what I wanted to show you. Back to PowerPoint. That's where we were. So I'll go back to my desktop. So next we're going to be using the switch, the ADC, and we're going to make the LEDs flash in a sequence with reverse. This is the classic microchip demonstration. But they don't really explain how they get you to this point, but I will, okay? So that is part 6 using the reset button on a 16F175 chip family. Enjoy.